So with that, I'd like to introduce myself. My name is Mike Grove. I'm founder and VP of engineering here at Stardog. Got a long-standing interest in the intersection of graph and AI and semantics, and have been putting those interests into the Stardog platform, and I'm excited to be chatting with everyone today. So with that, let's get started on our webinar, how to transform your data into an asset with a knowledge graph. So, everyone has the belief that data is very valuable. There's been a lot of different ways people frame that sentiment. Data is the new oil, the new gold. There's been 1,000 different ways. The sentiment has been expressed by 1,000 different people. And, it's something that's also been picked up by industry analysts. People like McKinsey and The Economist have published studies showing that companies who more effectively leverage their data have better business outcomes than those that don't. So, clearly everyone recognizes the value of data and certainly believe it to be an asset. And, some have gone so far as saying it's the most strategically important asset of the organization. But, assets have value. So, with everyone thinking the data is valuable and that it's an asset, how do you put a number on that? How do you define that value? From a mundane perspective, when you're trying to get a new data-driven initiative greenlit, if you're more able to put kind of a concrete value or an ROI number on it, you're more likely to have success moving forward. Fortunately, Gartner's done a study about infonomics, and the results of that study show that there's up to a 3x improvement in market valuation for data-savvy companies, and the ones that are most able to effectively leverage their data when compared to more traditional or more conservative brethren. So the market's clearly establishing a book value of data. It's not, a nebulous thing. Because data in the past perhaps was tricky to put a value on because you can't wrap your arms around it and you can't see it. But clearly the market's telling us what the value of data is. So then the question is, if data is valuable, it's clearly an asset and the market recognizes that, how are companies realizing that benefit and seeing that change in their market cap? So the interesting thing is a lot of the data initiatives, a lot of these data-driven projects that companies undertake, they come in a lot of different shapes and sizes, a lot of different ways for organizations to realize the value of the asset that they have at hand. We've been lucky enough to see companies be very successful on a variety of these fronts. Customer 360 is probably the most famous and well-known of these initiatives. But we've seen a lot of projects in the financial domain, particularly with the effects of external regulatory authorities. So, that looks like SR 14, MiFID 2, BCBS 239, more generally for companies operating in Europe, GDPR. We see similar external pressures from like the FDA in the States for bio and pharma companies as they try to bring new drugs to market. In manufacturing, that looks like supply chain optimization and predictive maintenance. So a lot of different ways and shapes that organizations are trying to use their data. So before we move on, I just want to start a quick survey for the folks attending the webinar. Which of these goals are you trying to do in your organization or that you're a part of? And we'll review the results in a moment. So, one of the underlying themes here of all these data goals is, obviously they're based on the fact that they need data access, and all is around trying to monetize the asset of their data. And that kind of tends to take two forms. Gartner talks about these as direct and indirect monetization. Direct is pretty obvious, basically selling your data. So, the Facebooks and Amazons of the world, this is kind of how they're using their data. So they're directly monetizing data. But where the majority of companies end up is in that indirect monetization. So to look, for example, at supply chain optimization, trying to eke out that extra percentage or two of operational efficiency, the amount of money that these organizations save at scale, that's significant value to them. That's where they're deriving indirectly value from their data. For the predictive maintenance use case, spending the money to do low cost regular repairs to machinery rather than having to incur the big costs of significant failures of those machines, potentially having to replace them. Another way that these organizations are indirectly monetizing their data. The most effective organizations, the ones at closer to that 3x multiplier, tend to do both of these to the greatest extent possible. But what we commonly see is a lot of the indirect monetization is certainly where organizations start. And then before we kind of move on, just to go over the poll results, it looks like knowledge management, so in smart internal search, scientific research applications is the chief amongst the webinar attendees, but coming up closely, operational efficiencies, product improvement, which is what we also see out in the marketplace. So data is an asset, and organizations are trying to realize it. Obviously, it's not ever that easy. So what we see is a lot of common barriers that organizations run into, and all these barriers are interrelated in some way. We list them here separately, but you can't really tackle them one at a time. You have to have more of a holistic approach to how you treat and use data to effectively be able to realize the value of it as an asset. So the first barrier we'll talk about, and again, we're going to kind of just quickly go through these at a high level, and then we'll dig a bit deeper into each as we move on. The first one is access. It's no secret that the enterprise data ecosystem is highly siloed, and one of the biggest challenges organizations face is simply getting access to their data. You can't realize its value if you can't even put your hands on it and begin to use it. So access is primary amongst these common barriers. Next up is purpose. One of the ways that organizations try and tackle the problem with access is to start centrally locating a lot of data. But what that ends up looking like is a lot of process without really any single purpose. There's a belief in the organization that they need to effectively or more effectively use data, have a better data strategy. So you get a lot of work done to bring that data together in a single place, but it's not clear what's there. It's not clear what any of that data means. And this is where we typically see data lakes devolve into data swamps. Next up, analysis. And this is one that really hinges on the previous two. You're not going to be able to effectively analyze the data if you can't get your hands on it, or if there's no coherent purpose or coherent meaning to that data. And finally, organizations understand how big of a change agent using machine learning can be within their organization. And there's certainly a lot of interest in being able to bring it in and leverage those capabilities. But like analytics, machine learning is hampered by poor data, incomplete data, incoherent or unavailable data. So that makes the use of machine learning within these organizations a lot less effective. So before we get into our first use case, I just want to fire off another poll. Curious, before everyone told us what goals they're trying to achieve within their organization, now which of these barriers are in your way primarily from preventing you from being able to effectively realize the data goals that you have? And we'll go through this next use case, and then we'll review the poll results after that. So the first use case here is with our friends at NASA. They've built the Human Spaceflight Engineering Knowledge Graph, and they've had a little bit of problems from each of these barriers, but two of their primary challenges were dealing with access to the data and the purpose of the data. You know, NASA obviously has a very challenging mandate of putting people safely into orbit, getting them back. So their tolerances on having good, accurate data, having access to all of the relevant data as they try to make decisions is very important to them. One of the most important things that they're trying to drive forward with their spaceflight engineering knowledge graph is understanding the implications of changes to spacecraft. Obviously, they want to keep the astronauts safe, so if someone's trying to make a change to the propulsion system in the spacecraft, NASA needs to make sure they understand exactly what that means to not only the propulsion system, but to the spacecraft as a whole, as well as the human astronauts inside. So previously, each of these changes was a process and a project in and of itself. It was a 6 to 8 week manual effort where engineers were pulling data from different systems, trying to analyze it, understand it, and then create a report so they could figure out if the change was something that could stick or if they were going to have to go back to the drawing board. This was really slowing down NASA's ability to iterate quickly on designs as they try to get back to the moon and Mars as is part of their mandate. So they put together the Human Spaceflight Engineering Knowledge Graph. It aggregates 24 different data sources across NASA and has a variety of different data types, both structured and unstructured, from a variety of different disciplines. And the big change for them is that they've gone from 6 to 8 weeks to generate a report to 6 to 8 hours. So they're able to move much more quickly and have better idea of the implications of their changes to their designs, and hopefully get to a better end result by using the Human Spaceflight Knowledge Graph. And this is something that is an ongoing living effort for them. They hope this ends up as part of their mission control operations as the designs move into NASA's version of production, which is outer space. Looks like the results of our poll, access, the primary barrier that folks are facing, which is not surprising. That's why we've listed it first here. That's the primary challenge that we have seen amongst our customers. It's no secret how siloed the enterprise data ecosystem is. Each line of business has their own systems, their models, their own apps, schedules, objectives, and then trying to access data across the lines of business is similarly challenging. You get turf wars over data, people will be very protective, fighting bureaucratic red tape. So, this is one of the chief liabilities that these organizations have in their move to more effectively leverage the value of their data. And the variety of data exacerbates the problem. And that's not getting any better anytime soon. Everyone talks about the explosive growth of the volume of data, and everyone focuses on that V of big data volume. But what isn't talked about necessarily is you get a correspondingly large growth in the amount of data variety. And unfortunately, our best way to address the challenge of data variety is by making more silos. So we end up making the problem of access worse. We keep putting data in isolated systems and content-specific systems. We stand up another data source, another lake, another warehouse, and that further complicates our priorities for access. So, what organizations need to be able to tackle the access challenges have a different perspective. And they need to really understand the fact that the business doesn't really care about where data is stored or how it's stored. The questions that the business asks are independent of the location of the data. No part of the business is asking for performing some analytic over just the data that's in Mongo or just the data that's in the data lake. And this is the primary way in which silos are a liability and prevent and hamper access. You end up having to make these compromises sometimes and execute that analytic over just what's in the data lake. So organizations need to start focusing on simply using the data and not worrying so much about where the data is or how it's stored, and leave how it's stored as a concern for IT. Because again, the business doesn't care about those silos. So, how do they stop worrying about the fact that the silos are there? by adopting knowledge graph and recognizing the fact that graph is the universal data model. It's the most appropriate data model for the business. So this lets you use knowledge graph as an appropriate abstraction for data within the organization. And once you do that, you're able to make this pivot from kind of this database or storage-centric approach to more of a data-centric approach. And you're able to talk about the data of the business in the same terms of the language of your data and the language of your business kind of converge and come together. So you're talking about data as people and transactions and projects and SKUs and their relationships. And you're not talking about keys and values or rows and columns. And because you can do this in place without disrupting your existing systems, you're able to kind of build up this over time and leverage that abstraction very powerfully to start adopting this approach, one step at a time in a very agile manner. Our next use case is a great example of being able to do this. So Bosch has quite an expansive product catalog, over 50,000 products, and they're launching many more each year. And as online commerce becomes an increasingly important focus for them, being able to streamline their customers' access to information about their tools and hopefully make it easier for them to purchase them, is something they're very acutely focused on. So they built a product recommendation engine on top of their Power Tool knowledge graph, and this brought together data from structured sources that was simply what the product catalog was, what the tools are, the specifications for them, but also brought in a lot of interesting related pieces of content. A great example is they were making kind of how-to videos that showed how to use the latest power drill, for example, for a DIY home project. So to be able to pair just the structural information they knew about their product catalog with a lot of this new and interesting content that would help get people to the right tool and give them some ideas about how to use it, maybe give them some ideas about other tools that they may need to complete the projects they have in mind, has been a very powerful piece of infrastructure for Bosch as they move forward with this as part of their website. The next area we want to talk about today is, we've got it labeled here, purpose. So collecting data centrally, is a way that organizations try to circumvent or address the challenges of data access. But that ends up being not very fruitful because there's a couple challenges that they struggle with as they try to make this change. And one is putting two pieces of data next to each other doesn't really align them in any way. It doesn't make them agree on any context or meaning. So you end up having to create a very general interface, and that puts the burden on people who need access to the data. So they end up having to reinvent the wheel to understand the data as they go. So the data loses some of its context when it's just kind of thrown into the mix without any kind of coherent plan. It also ignores the fact that we showed earlier the explosive growth in data volume. There's always going to be data in another location. The growth is going to outstrip our ability to physically move it into a single place. So we're never going to have that complete picture when we presuppose that we have to move all the data together. And as part of that explosive growth, we see a lot of that in unstructured. So increasingly, that means you need a more generic interface, and that makes it harder to maintain the context of the data as you try to physically bring it all together. So where the knowledge graph tries to address this problem is by using the flexibility of the graph. We said before was the universal data model to talk about and frame all the different types and ways that organizations store data. So it becomes the appropriate way for us to work across all the different types of data in the organization. And it can work in hybrid environments, so data that's on-prem and in clouds. We're using the graph to, again, abstract away those challenges. And then because we're able to use graph as that abstraction over the source data, we're able to more appropriately apply the original context to that data and even enrich it. and provide more concrete definitions of what that data means. And that increases the data utility for all of those downstream data consumers who are trying to bring this data together to meet the data goals of the organization. This has been being able to make this change, and I said before, it requires a bit of a reframing of your perspective, but it can be a huge strategic benefit for folks who have been able to do that. When you're able to stop worrying about how the data is stored and start focusing on the data itself and how you can use it, it really unlocks a lot of the possibilities of what you can do with the data and how you can actually effectively meet those goals that we talked about at the top of our conversation. So another use case to go through is a great example of where putting the data together in one place wasn't ever going to be an effective solution. So our friends at Morgan Stanley were trying to build an IT infrastructure knowledge graph. Their original use case was to do outage analysis to understand what are the effects to the business if a network or a server goes down, what's affected. That's certainly something where you can't operate on a stale copy of data. If the copy of data that you have at hand is the data from yesterday, there's no way you're going to triage an outage that's happening right now. And it's another case where there was always a bit more data. There's always somewhere else, some other interesting piece of the puzzle for their IT infrastructure that they wanted to bring in and be able to create that kind of master single source of truth across all of the different places and ways that they talked about their infrastructure. So being able to have the advantages of the centrally located data without physically moving it anywhere gave them the ability to use the most recent and accurate data, but also gave them a flexible platform to begin to add new related data sources. And that let them expand out from their original use case of doing outage analysis to other related areas such as insider threat detection. You can imagine a bank's storing bank account information, so to understand who within the walls of the organization has access to that data. People focus on external threats, of being able to put this data together gave them the ability to start looking at internal threats. And similarly, they were able to spider out and use that as part of their toehold to support their GDPR efforts, because they knew where data was stored and what kinds of servers. So that gave them the ability to start supporting those efforts for the European regulations. And then very simply, the original use case, they saw a very similar benefit to what NASA was. Their hours-long outage triages, which at times lasted longer than the outages themselves, they were able to get down to a single query that was answered in less than a second. So not only did it ultimately make them a more effective organization by letting them support multiple use cases, it helped them solve more capably their original pain point. So next up, analysis. Analysis is very tightly coupled to the previous two barriers. I touched on it earlier. It's hard to analyze data if you can't get access to it. It's hard to analyze data if you don't understand what it is. There's no kind of central or coherent purpose to the data. And this is what has led, and this talked about everywhere. Data scientists I have talked to said this number is entirely too low. But generally people say that data scientists are spending 80% or more of their time not doing analysis. They're not doing their jobs. They're spending that time instead kind of fighting the barriers of access and purpose. They're the ones that are wrangling and munching the data and trying to bring it together in a way that's coherent, that they can get on with their job of being able to analyze that data. So, this is where we see the knowledge graph makes a significant difference by letting the data scientists in this case, or business analysts, application developers, anyone else who's kind of working in this space, leverage the network effect you get from bringing together different sources of information in the org. So the knowledge graph ends up becoming something that's worth more than the sum of its parts, and the cost of putting those parts together decreases as you go, because you kind of get this snowball effect where you're not duplicating efforts, and you're taking advantage of the flexibility of the graph and the abstraction it provides from the underlying way in which data is stored, so you can more agilely respond to new requirements, new questions that come up. There's always a next question when you're doing analytics. You get some conclusion, and that leads to an aha moment, and then you always have a fundamentally, what's the next step, what's the next question to answer now that we've answered this one. So we see significant benefits as people go using the knowledge graph, because they're more flexibly addressing these challenges as they come up, and they're more able to move at the same speed that the business is moving. One final point here for this section, we talked about, again, the explosion of data variety, unstructured being chief amongst that. And this is one of the most rich sources for information for analytics that organizations aren't tapping into. So Gartner calls this dark data. And the only way to shed light on that data and kind of bring it into the fold is being able to have the flexibility and the infrastructure to expose that out to the people doing the analysis, so to facilitate the access to this data. And this is where, again, we see the benefits of the knowledge graph and the flexibility of being able to adapt and bring in the emails and contracts and documents, images and videos, Twitter streams, and treat those as information sources just like any other structured system, such as Oracle. Really puts a lot of power in the hands of data scientists that they otherwise don't have, or is the difference between them spending all of their time doing this work by hand. The final barrier to touch on here is adoption. We said everyone understands kind of the transformative effects that the use of machine learning can have within the organization, but the one thing that often isn't talked about is how dependent machine learning is on, much like analysis, on access to the data and good, coherent, complete data. Machine learning is kind of very data driven in that if the data coming into it is incomplete, it's incorrect, if it's out of date, the results from the black box that is machine learning reflect those biases in the data that's fed into it. So to really get the full power you need from machine learning, you have to be able to feed it a good data set. So, what do organizations struggle with now as they're trying to adopt machine learning? Because it's a black box, because the data going into it is often incomplete or out of date or incorrect, it makes it hard to trust, because you don't really understand where those decisions are coming from, and you understand that maybe the data going into it isn't perfect. So trying to explain the results, especially when the results you get are surprising or counterintuitive or invalidate the hypothesis that you had natively, being able to have that transparency into the process is key to really embracing the use of machine learning in the organization. And this is where the knowledge graph can really benefit, not only in kind of knocking down the barriers in access and purpose and feeding good data, complete data into the algorithm so you get the most out of the algorithm. You then have that traceability back from the machine learning process all the way to the source system. So you understand where that data came from, what it means, and that gives you the context and the understanding to understand the decisions and the output from that process, and gives you more confidence that you can go with the recommendation that it's making. So, the one thing to kind of wrap up here, I mentioned it earlier, is you have to have a coherent strategy. You can't just tackle a barrier. If you focus just on promoting data access and you end up just consolidating everything into a data lake, you've just created a new set of challenges for yourself. So you have to have a more holistic approach. So you have to really make sure you develop a data strategy, and a key part of that is being incremental. And this is where you can take advantage of the fact that you don't have to boil the ocean with the knowledge graph. You start with a key use case. Oftentimes, that's a single thing within a department in a single line of business. and you take a couple of sources and you make a small knowledge graph, just what you need to satisfy that use case. And then, like we saw with Morgan Stanley and others, once you've kind of achieved that initial goal, there's a related use case that's just one or two data sources away. And then there's another one that's one or two data sources away. So you're able to have this very agile approach. You can kind of treat these things as sprints and glue in a data source every 2 weeks and incrementally increase the value of the knowledge graph to the organization and increase the breadth of the use cases it's able to support. So, the best place to start again is you pick that key use case, figure out which are the couple data sources that are primary to being able to solve that. Ideally, bringing together data across silos and start with connecting that and bubbling it up to solve that use case, and then work onwards from there. So now I want to, before we get to our Q&A section, talk a bit about how Stardog is unique. I've touched on some of the key factors for knowledge graphs, as we've gone on today, but now I want to talk a bit more about Stardog specifically. So, Stardog focuses on providing, a foundational piece of infrastructure for surmounting these common barriers that organizations have for achieving their data goals. So we use graph as kind of the fundamental abstraction for all data in the organization. So, again, you're not focused on how data is stored. You're not worried about tables or keys and values. You're worried about the data itself. So in that way, your knowledge graph acts as this appropriate abstraction. So the business forgets that those data silos and that wide variety of data even exists. And it gives you that single logical access point, and it gives you a place to apply context and meaning to the data. But that context needn't be a single definition for the entire organization. The most appropriate way to do this is to let people treat this context in some senses as a lens and look at the data in the way that's most appropriate for them for their use case. So you can have kind of people apply different contexts and understand and highlight different parts of the data that's most important to them for their use case. And they take advantage of that aspect of having that rigorous logical model for the data and having it decoupled from how the data is stored itself. So, how do we do that? A big part of it, and we're proud of, is the surface area of the knowledge graph is all standards based. That means, the query language, the data model, the data format itself, these are all standards in the same way that HTML is a standard. So that makes it easier to interoperate within the organization with other parts that haven't yet adopted the knowledge graph, or amongst different installations of a knowledge graph within the organization. It's built for AI, understanding the power of having machine understandable data that you get from having that logical data model and thinking about data in a very high level context and not having to focus so much on how it's stored. So you're able to bring very powerful AI techniques, including machine learning, to bear on that aggregated view of all the data in the organization. So, and we're taking advantage of the flexibility of graph, so that lets us represent and use the fact that graph is the universal data model and accommodate structured and unstructured all under one roof, but being able to flexibly virtualize that data and not have to physically copy it into one place. And that makes it easier to respond to the fact that there's always data somewhere else. And you can very easily bring in those new data sources as they come up and increase the value of the knowledge graph by integrating them and unifying them with the rest of the data in the organization. This is something, I said we've had the fortune to work with a lot of different companies that are trying to achieve a variety of different data-driven goals. So just a summary of some of our customers here that have seen the benefit of this approach in using knowledge graph in their organization to be the way that they think about and talk about data. And it's let them flexibly adopt this new kind of shift. And they've been able to really see the benefits of using graph in their organization. It's really supercharged their abilities to do analytics and machine learning on top of the aggregated view of all the data in the organization. And we breaking out some of the use cases we've seen across our customer segment, these should look a lot like the data goals that we talked about at the top of the hour. So this is the nice thing about having that high level representation of your data. You're able to flexibly accommodate each of the different ways that organizations need to use data within a department or across departments, across lines of business within the organization. The knowledge graph's flexibility lets you meet all the different objectives you have for using data. A couple ways to learn more about using knowledge graphs. We have our Knowledge Graphs 101 white paper. The link's here, and you can come to stardog.com, grab a copy of the software and try it out on your own, which we encourage you to do. And before we get into the Q&A, I just want to launch one final poll. Where are you on your journey? How are you looking at turning data into an asset? Have you not begun, or are you done and you just wanted to hear more about Stardog, or somewhere in between? So encourage you to vote as we go through the Q&A section here. As a reminder, if you have questions, put them in at the bottom of the screen at the Q&A button, and we will get to all of them. If we run out of time, we're not able to get to all the questions, we will make sure that everyone receives an email with answers to their questions at the end. So now for Q&A. First question we have is, how is the logical data model expressed? OWL, shackle, something else? So specific answer is OWL. So that it's OWL and RDFS. For presumably you're familiar with the acronym SOUP, that is the semantic web. We do also support shackle. Shackle is typically used for data quality constraints. That is saying, my knowledge graph must or must not look like this. So that's kind of the fundamental data representation format that we use in the knowledge graph. And that's really what you need, because you're talking about data at a high level, and OWL gives you the primitives to be able to do that effectively. The next question, the key to using the knowledge graph must be understanding the underlying model. How can you find and grasp the parts of the models required to use the graph effectively? So I think you're asking about trying to understand the overall data model of the organization, which is certainly true. You need to understand that to be able to effectively use the knowledge graph. But I think where that's a lot easier is because the data model, the knowledge graph, kind of ends up being the same way that we talk about data in meetings or at the whiteboard. And you're not hung up on details about how normalized or denormalized the relational schema is. That's kind of an implementation detail that isn't bubbled up. You're really focusing on the concepts in your domain and how they are related to each other. And this is the way in which graph is a perfect fit for utilizing enterprise data. All those data goals that we talked about, they all hinge on being able to effectively understand the connections and connectedness of the things in our world. And this is what graph is all about. Another question concerning mappings. How do you map the contents of web service messages adhering to different schemas onto knowledge graph concepts? So the short answer for that is you want to kind of align, if you think about it in like a relational sense, you want to say, this contents of this table correspond to this entity and this type of entity in my domain. So customers are in this table, products are in this other table, the purchases those customers have made. It's a foreign key here, primary key there. That's in this other association table. And so the mappings are primarily focused on bubbling up those relationships from the underlying data storage aspects to this high level model. Since you knew about OWL and Shackle, one way this is done is through R2RML, which is another W3C standard that we support. Another question we have here, what's the difference between a graph database and a knowledge graph? Which is a great question. Our knowledge graph platform has a graph database at its core. So the quick answer would be knowledge graph is a superset. But I think where you see the big difference is graph databases tend to end up becoming graph silos or a graph data warehouse. They're great for very point use specific, very graphy use cases. So if you're doing click detection, they could be a great choice for that, but they're not appropriate for being able to unify and align data across the enterprise. They don't have any ability to bring together different sources of data. They use different types of different data varieties from all over. And so graph databases, if they're in use of the organization, are a great part of the knowledge graph, just like Mongo is or the data lake is. Next question, what data would I want to store versus virtualize? Which is really interesting because it doesn't strictly matter. And that's some of the benefit that you get from the abstraction provided by the knowledge graph. Whether something is materialized or virtualized ends up being an implementation detail. So that's something that someone in IT worries about. But your data scientists, your business analysts, application developers building stuff on top of the knowledge graph, they're just going to use the data as is. And if behind the scenes some of that data is physically materialized into the knowledge graph for performance reasons, then that's great. If it's virtualized because, like in the Morgan Stanley case, it's effectively live data and you don't have a choice, that has to be virtualized, that's great too. Certainly in all deployments that we've seen, it ends up being a mix, and you can change behind the scenes as your use cases and requirements, your SLAs evolve over time. And last question, how does Stardog enable explainability? So I think that's pertaining perhaps to explainability in using machine learning, or more generally in the data itself. The really great thing that you get about having this logical data model is you understand the context of the data and how the different parts of it come together. So, a lot like in high school algebra, you had to show your work to get full credit for an answer to a question. Being able to have that logical data model as the way you describe the data gives you that ability to show your work. So you have a lot of explainability in, why is this the case? Why do we believe that this could be a fraudulent transaction? Or why do we believe that this is a customer who is a churn risk? We're able to tie that back to all of the original data points, irrespective of which system they come from, all of your business rules that you've encoded into the knowledge graph that kind of leads you to that conclusion. And then being able to have all that context, if you then choose to put this into a machine learning algorithm, understanding where that data come from, what it means, and the implications of it gives you a better understanding of being able to traverse that graph and makes those answers that you get at the end more coherent and more explainable.